Okay, day 8, last day of lessons, guys. We're going to start with linear inequalities. Now, you're going to use the same format of slope-intercept, y equals mx plus b, but now instead of equals, you're going to see these two symbols, a greater than or a less than, okay? So let's just pretend we have the same line. So let's just say we have a starting point of 1 and a slope of up 1 over 2. So your line goes from here to here. Do the same thing over here. Now, starting point, slope. So let's say we have the same slope and the same starting point. The first thing that's going to be different is you're not going to draw a line. You're going to draw a dashed line, or a broken line, or a dotted line. As long as you show that it's not a complete line, that it's missing something. Now the reason that this is a dashed line is because your answer isn't actually on the line. No, your answer has to be greater than the line, or your answer has to be less than the line. So how do you show that? Well, when you see y is greater, when you read this out loud, what that means is your answers have to be above the line. So what you do is you shade above the line, and that's where your answers are. Any point that is above the line is an answer. So instead of putting points all over the place, you just shade above the line and you represent this area as your answer. This is where your answers are. Now this one says that y is less than the line, less than mx plus b, so you shade below. That means your answers are below the line down here, in that area, okay? So that's how you're gonna graph inequalities. Now, there is a second kind. What if it says greater than or equal to? What if it says less than or equal to? So when there's a line involved, now your answer can include the line. So if you see this symbol, you can draw a regular solid line. You just draw your regular line. That means that your answers on the line are also included. So you have a regular line and you still shade either above or below it, but now your line is a regular line, which means your answers stop at the line. At the line, you can have an answer on the line, but nothing past the line. Before, it had to be on the other side, okay? So those are inequalities. So a quick example, we have a slope of -5. So 1, 2, 3, 4, 5. The slope is up 2 over 3. 1, 2, 1, 2, 3. Now before I draw my line, I look at the symbol. Is there a line underneath it? Yes. Then I'm going to draw a regular solid line, not a dashed line. What does it say about the line? Now, when I shade it, this really doesn't matter. What matters is right here. What does it say about y? Because you're talking about the y-axis, this right here. Is your y greater than or less than? Y is less than. That means less than the line down here. So you shade down here. And that's it. Okay, and that's how you graph inequalities. Now, there are two kind of strange cases. You have a case both like these. So here's what you do in these cases, all right? When you see x is greater than 5, when you just see x and nothing else, they're talking about the x-axis. So where is x5? Right here, right? It's right there. So when you see this, instead of doing a diagonal line, what you're going to draw is a vertical line. Now, what kind of line will it be? There's no line underneath, so I'm going to make it a dashed line. So it's a dashed line at 5. Now, what does it say about x? X is greater than 5. So think about it. If this is x, and this is 1, 2, 3, 4, 5, where are the numbers greater? 6, 7, 8, 9, 10. So we're going to shade over here on this side. Okay. Now, if you see y and nothing else, well, you're still going to mark where y is at -3. 1, 2, 3. -3 down here. It's going to be a solid line, but it's going to be a solid line that goes like this. And then you read it. What does it say about y? Y is less than or equal to -3. less than or equal to -3, so below -3. And that's how you answer that. Okay, so those are two special cases. The last thing I want to point out to you is here. If you have a word problem, okay? So if you have a word problem, just be very careful how they lay it out for you, okay? So let's say you have a budget of $90 to buy water and soda for a party. If you buy 9 cases of water at $4 each, how many cases of soda can you buy? So let's just make water is X, soda is Y. The water costs $4. Soda costs, doesn't say, let's just say $6 sodas. Let's say the cases for soda are $6. Okay, so I put 6Y. Now, when you add them up, you need to meet your budget. Now, can you go over your budget? No. So you have to spend less than or equal to $90. This is the equation. Now, what you would then do is rewrite this in a way you can graph it. So guys, how do you change an equation so you can graph it? Well, it needs to have the y by itself. Y needs to be alone. Okay, so what do we do here? Let's move the 4x. Now 4x is over here. Get rid of the 6. Let's divide by the 6. So get everything divided by 6. You get, your answer will be -2/3 x plus 15. Okay? Now, you would graph this. You can graph it basically. Starts at 15, goes down 2/3, down 2/3, down 2/3. Your line would look something like that. Okay? You would shade below. So you can spend, basically, if you shade below, what you're saying is your answers are down here. The problem is they want an exact answer. They want to know what happens when you buy 9 cases of water. So the easiest thing to do is to just plug in 9. Plug in 9 and solve. If you plug in 9, you get 9 times 2/3, you would get -6. -6. So then you get -6 plus 15. Oh, guess what? The point on the line would be 9, 9. If you buy 9 cases of water, you can buy 9 cases of soda and still be at budget. Okay? So those are how word problems work. So that's it for the first lesson.